Please remind me to record it. Otherwise, I forgot many times. Sorry about that. Okay. So in this section, we are studying linear approximations and differentials. Okay, we know that if we're given a function y equal to fx, suppose we have a graph here. Anything like this, right? Then the hi, Michael. And here is any given point A. We have, this is f of A, right? This is the line, the curve y equal to fx. And this is the tangent line at this point, at the point P, at A and FA of the curve here. So imagine that if you zoom it in, you use a microscope to zoom it in, and it will be somehow like this. Right, this area. So, and this, the red line, we call it linear approximation of the curve y equal to fx. So doing this, we can approximate the value of the function f of x by using a linear lines here. Okay. So, so in this section, we will study this. So we will use the tangent line at the point A, f of A is an approximation to the curve y equal f of x. Okay. Because we use a tangent line to approximate this curve. So what is the equation of the tangent line? At the point A, FA? It is y minus FA equal to m, yes, m times x minus a. And this here, the slope at this point, we can use the derivative of this, right? So it will be y minus fa equal to f prime at a times x minus a, right? So now let us isolate y. So how can we do this? How can we isolate y from this equation? Yes, we add both sides by f of a, right? So the right-hand side, we just rewrite it. Very good. Thank you, Andre. So we see that f of a is a number, right? A is given, then f of a, the function f is given. So f of a here is a number. Similarly, if we're given the function f, then we can compute f prime. F prime at a specific point when x equal to a, it means that this guy will also be a number, right? A is given, it is a number. So the right-hand side is a polynomial of degree 1, or it is a linear equation, right? And so that is why we call it linear approximation of the function f of x, of the curve f of x. And let us call the function L of x is fa plus f prime a times x minus a. So we call it linear approximation, the linearization of f at a. Okay. It means that the approximation f of x, the function f of x is approximate by f at a plus f prime at a times x minus a. Okay. Sometimes we call it the tangent line approximation. Okay. So the idea is basic, right? We approximate a curve by its tangent line at that point. So now let us play with an example and see how it looks like. So example, we are given, okay, find the linearization. Excuse me. Of the function f of x is the square root of x plus 3 at x is equal to 1 and use it to approximate the number square root of 3.98 and the square root of 4.05. Are these approximation overestimate or underestimate? So this is the question. Okay. And when I type SQRT is the square root. Okay. Okay. Or let us summarize it a little bit. So now we are given that y is equal to f of x, which is square root of x plus 3, right? We need to find the linear approximation of this, and the linear approximation of this is Lx, which is f at a plus f prime at a times x minus a, right? And we're given that a here in this situation is 1, right? So let us write it clear. So it means that we need to find L of x at f of 1, and it would be f of 1 plus f prime at 1 times x minus 1. That is what we are asked to do, right? So from this, what do we need to do here? What should we do now? Let us do an easy thing first, right? Evaluate the value of this at 1, okay? So we need to find f at 1. We need to find f prime at 1 and put it into the formula. Then we have the linear approximation of this. Okay? So from this, what is f of 1?
2.
Perfect. Who was that?
Michael.
Michael. Thank you, Michael. And it is very fast, Andre. So it will be square root of 4, which is 2. Okay, very good. And how about f prime at 1? Before computing f prime at 1, let us compute the first derivative of a general x so that we can review the formula, okay? So it is the derivative of square root of x plus 3, which means it is the derivative of x plus 3 to the what? Yes, to the 1/2. We take derivative of the whole things here, right? Now, our job is to determine the correct u, the chain rule. And u in this case is x plus 3. Faith explained us very clear in the group chat if we can determine the correct, this is some side computation. if u of x, we define it x plus 3, then here it is equivalent to computing u prime of u to the 1/2, then take the derivative, right? And sorry, this is 1/2. And how does it become? Yes, or do it slowly. 1/2, then u to the 1/2 minus 1, right? And the general tell us that, okay, we need to compute u prime, okay? Then this is side computation. We can put in here. So in short, what is it? One-half and u to the negative 1/2, or we can write it 1 over square root of u, right? The same things. And square root of u, and u is x plus 3. Then u prime here, u prime, which is x plus 3 prime, give us what? 1. Yeah, very good. So just do it slowly. Then finally, the general form of this will be 1 over 2 square root of x plus 3, right? So just determine the correct forms and you'll be fine. Very good. So we have the general forms of f prime. So we need to evaluate the value of f prime at x is equal to 1. So what do we have?
1 over 4.
Yes, very good. Who was that? I'm sorry.
It was Michael.
Thank you, Michael. Very good. So we know f prime, we know f, and the point. Therefore, the linear approximation of the line is f of 1, which is 2 here, right? Plus f prime, which is 1 over 4, times x minus 1. Oh, sorry. So it's easy, right? Nothing difficult. But now, can we simplify it or write it in better forms? When we distribute this, what do we have here? Yes, 1/4 times x minus 1 over 4. Thank you, Gregory. So here, so there's a number and a fraction. What should we do? Say it again, please. Yes, find the common denominator, which is 4. It means that the number 2 here, we must divide it by 4 and multiply by 4. Be the same thing. Now they have the same common denominator. We can add the numerator together. And the numerator here is 8. Add with negative 1, which gives us 7 over 4, right? And this 1 over 4 times x, then it will be 1 over 4 times x, or x over 4, it is the same things, right? And the number here, as we mentioned, it is 7 over 4, okay? This is the linear approximation of the function f of x is square root of x plus 3 at the point x is equal to 1, okay? So, or we can write it like, okay, square root of x plus 3 is approximate by this linear equation, right? We use this sign, approximate. Very good. It means that we can evaluate the value of the function near 1 by using this formula, the formula of the linear function here. So the next questions, they ask us to compute, in particular, we need to compute square root of 3.98. Okay? If we have a calculator, we can type it easily, and we got that in forms of real numbers. But we don't want to do that. We have the approximation on top of this. So let us use it here, right? Let us use this one. But before using it, we need to make it clear. Here is something plus 3, right? And our numbers here is 3.98, which is, can we separate into something plus 3? Perfect.
0.98.
Very good. Thank you. Was it you, Michael?
Yes.
Thank you. So here, from this, 0.8 is near 1, right? It's near 1. Therefore, we can use this approximation to approximate this value, which will be, what is it? Perfect. 0.98 over 4 plus 7 over 4. Very good. Thank you. So, and you can use a calculator and it will be 1.995. Very good. Similarly, for another number, square root of 4.05. So let us write it in terms of something plus 3, right? What is it?
1.05.
Yes. Which will be?
1.05 divided by 4.
Very good. And it is 2.015. Okay? That is what we have. We approximate this number by using this formula, and we have this numbers. Okay? But we know that we can use calculator to find the exact value of this, a better result, which is 1.994994. And square root of 4.05 is 2.01261. We use calculator. What do you think about these results? This and this one.
They're pretty close.
Yeah, very close. Very good. They're very close. But the formula here, it gives a bigger value, right? Similarly for this situation. So therefore, to answer the last question of this example, we say that it is overestimate. Right? Okay. Thank you. So, very good. So if you go online or using Desmos, something like that, we evaluate, we can make a graph of this equation. This curve, we see that at -3, so the function x plus 3. At -3, it is 0, right? At 1, it would be 2. So it goes through these points. And the domain is from -3 to infinity, okay? The linear approximation is the line here, the tangent line here. This is L of x is x over 4 plus 7 over 4. And here is the function f of x is square root of x plus 3. So we see that the red line is over the green lines. So that is why when we evaluate the value near 1, the value of it is overestimates, okay? And that's it for linear approximation. So you can apply to any function. But we see that if we go far from this point, far from 1, this approximation get worse, right? It is good for the neighborhood only. Okay? Very good. So now, let us play with some other concepts. Differentials. Okay. So let me remind you about the formula of the first derivative. The first, if we're given a function y is equal to f of x, f prime of x is the limit when delta x, f of x plus delta x minus fx divided by delta x, right? Or we sometimes say that the change in y over the change in x, right? So look at this. Let us draw a picture of this. This is the coordinate. Suppose we have the curve like this and a tangent line at this point is like this. This is a FA, okay? And let us call it X here. And if here is X2, or let us x and x plus delta x. Sorry for making change of it quite often. So, and so if this is P, this point is R, and this point is Q. Okay, so delta x here, the change in x, right? This is delta x. And delta y is this part, right? So is it clear? The change in y in this curve f of x. And we have a new concept. The change from this point to the tangent line here. We call it differential y. Okay. So, or we say dx, which is differential dx, dy is differential dy. So we see that dy depends on, so, okay. And we write from this is a linear lines. So we have the relation that dy will be f prime at this point times dx, right? So we see that dy depends on x and dx, okay? So dy represent the change of the tangent line, while delta y here represent the change of the curve in the y direction, okay? Just some concepts. Now, but it is very useful. So let us play with this example. Compare the values of delta y and dy. If the curve y equal to fx is x squared, and x changes in two cases. The case one, from 1 to 1.05, b from 1 to 1.01. Okay. So we are asked about the changes here of delta y and dy, right? Let us write it down a little bit and clarify what we need to do. Right? This is the relation of dy and dx, while delta y is the change in y, right? Which is the difference of the 2 points. Let us call it x2 minus fx1. Okay? And dx, delta x is the difference between the 2 points. Okay. And from this, it is clear that, okay, dx is also this difference. So now our job, in order to compute delta y, we need to evaluate the value of x1 and x2. And in our case, x1 is 1, x2 is 1.05. Okay. Let us see. Now, in the case A, so it means that we need to compute, let us compute delta x first. Dx will be x2 minus x1, which is 1.05 minus 1. And what is it?
0.05.
Yes, very good. Thank you. So what should we do next?
Put it in the function.
Yeah, we need to put it into the function, which let us compute let us evaluate the value of f of 1, right? And f of x is x squared. It means f of 1 will be 1 squared, which is 1. Easy. Okay. How about the second point, which is f of 1.05? If you don't have a calculator, we can still do it by hand, which is 1.05 squared, right? And 1.05, it is 1 plus 0.05, okay? And then square. Take advantage of the perfect square formula. We have that it will be 1 squared plus 2 times the first number, which is 1, times the second number, which is 0.05, times the second number squared. One square is 1. This times 1 is 2. 2 times 0.05 give us what? Yes. And the last one, here, 0.05, 5 squared give us 25, right? And 0.05, it means that it is 5 times 10 to the minus 2. Do you agree? Which means it will be 5 squared, which is 25 times 10 to the minus 4 here. Okay. So sum them up. 25 times 10 to the minus 4, or we can write it 0.00025. Oh no, 25. No, 25. 10 to the minus 4. Okay, right? Then sum them up. It will be 1.1.025. Okay. So then what is delta y? Which will be minus 1. And what do we have in the end? Yes. Thank you. So that is delta y, right? So how about dx? So we know that dx is equal to delta x, right? Which is 0.05, okay? So we need to compute dy, which is f prime x times dx, right? In general, f prime here, where the function of f of x is x squared, right? And what do we have here? What is derivative of x squared?
2x.
Yes, thank you. 2x dx, very good. So we have this is the general forms of this. Then we need to evaluate at the specific point at x is equal to 1, right? So dy will be applying this formula. It will be 2 times 1, and dx here in this case is 0.05, and in the end it will be 0.1. Okay. So is it clear now? So this is delta y 0.1025, and dy, which is 0.1, is very close to each other. Okay. Very good. And similarly, in the question B, if it changes from 1 to 1.01, the same story, right? Delta x, which is 1.01 minus 1, and what do we have here? Yes. And in order to compute delta y, we need to evaluate the value at 1 and the value at 1.01, right? At 1, it is 1 squared, which is 1, easy. 0.01, what do we have? You can use your calculator. Okay. Then, no, 2, it means here, it is 0.2. Okay. So we know f at 1, f at 1.01, therefore, we can compute delta y, which is f of 1.01 minus f at 1, which will be 1.0201 minus 1. And what do we have here? Very good. And the same story. Dy will be 2x dx, therefore at x is equal to 1, we have dy will be 2 times 1 times dx. In this case, it is very good. And in the end, it will be 2.02 0, 2. Okay. So now look at this. The change in y previously, the difference between delta y and dy, it is 0.1025 minus this one, right? And the difference of them will be 0.0025. But here, when it closer to 1, the difference between of them will be 10 to the minus 4. It's smaller, okay? That is simply the idea of these two things, 3.10. So there are some more minutes here. Do you want to ask me anything about the quiz too? Any question? Sorry? Yeah, derivative. It is stated clearly here. So in the first one, you just do derivative, right? The second one, you need to use implicit function, then review it. The third one here, the equation of the tangent line at a specific point. So the same story, we need to compute the first derivative and we evaluate the value of this point, right? But look at this. This, it seems that we can simplify it. If we can do it, do it. So that we can do, we can get a better expression, right? Okay. But remember, the domain of this is x is different from plus and minus 2. When you simplify it, definitely the new function will have a different domain. But in order to compute the derivative at 0, 0 does belong to the domain of this. So it means that we're lucky. We can do it easily. So just a reminder, okay? So have a good one and see you tomorrow.
Would you want to simplify and then differentiate?
I'm sorry?
Do you want to simplify and then differentiate?
Yeah. You don't have to, but if you can simplify it, it becomes a lot easier. Okay? Just a hint for you. You're welcome.
Can I go back and do some one more any points at all or no?
You mean the